Episode 3. Title of the course: Advanced Materials. In Unit 1, in this Episode 3, we will discuss applications of ceramics and composites, SIAL system, technical ceramics, zirconium and silicon alloys, cements and concrete also. Few examples of how important ceramics are used to society. Impact on society. Refractories. We all know that metals and their alloys are used to make automobiles, machineries, plants, buildings and etc. of other useful things possible, but metal production would not be possible without the use of ceramics materials called refractories. Refractories can withstand high temperature condition encountered in the processing of metals. Refractory ceramics are enabling material for other industries as well. The chemical, petroleum, energy conversion, glass and other ceramic industries are upon refractory materials. Uses in the construction industries. The multi-billion-dollar construction industry areas such as commercial building, residential homes, highways, bridges and water and sewer systems. These areas which we often take for granted would not be possible without ceramic materials. Products such as floors, walls and roofing, tile, cement, bricks, gyms, swab pipes and glass are building blocks in the world of construction. What would our homes and businesses be if we did not have windows? The applications of glass in the construction industries include various types of windows to let in natural light. Approximately 3 billion square feet of glass is produced each year to make various types of windows. To put things perspective, imagine a 200-foot wide glass highway stretching from New York to Los Angeles. The different types of glass for windows include safety, stained, laminated and non-reflective. Additionally, glass fibers are used for insulating ceilings, panels and roofing, helping us to stay warm and dry. Clay bricks is used to build home commercial buildings because of its strength, durability and beauty. Bricks is the only building product that will not burn, melt, dent, peel, warp, rot, rust or be eaten by termites. Bricks comes in approximately 10,000 different colors, textures, size and shapes. Ceramic tiles is used in applications such as flooring, walls, countertops, fireplaces, etc. Tiles also is very durable and hygienic construction product that add beauty to any application. Next we will discuss about lightning electrical. An important invention that changed the lives of millions of people was light bulbs. This important invention by Thomas Alva Edison in 1879 would not be possible without the use of glass. Glass property of hardness, transparency and its ability to withstand high temperature and hold a vacuum at the same time made the light bulbs a reality. The evolution of light technology since this time has been characterized by the invention of increasingly brighter and more efficient light sources. By the middle of 20th century, methods of lights seemed well established with filament and fluorescent lamps for interior, neon lamps for exterior advertising and signs, and sodium discharge lamps for street. Since the time light emitting diode, that means LED technology, has been developed with application in watches, instrument panel indicators, telecommunication, that means optical fiber networks, data storage, that means CD, DVDs and document products, laser printers, etc. Next we will discuss about electrical application. The vast electrical industry would not exist without ceramics. Ceramics have a wide range of electrical property including insulating, semiconducting, superconducting, piezoelectric and magnetic. Ceramics are critical to products such as cell phones, computers, televisions and other consumer electronic products. Magnetic storage of data has developed in parallel with semiconductor computer chips and has been equally vital to computing and information handling. Without magnetic storage, there would be no internet, no personal computers, no large database and no gigabytes, terabytes and exabytes of data which computers now manipulate. Today more than 150 million hard disk drives and 50 million video recorders are made annually worldwide. Ceramics are even being used to enhance our sporting activities. Piezoelectric ceramics, piezoceramics are being used to make smart sporting goods, that is sporting good that can respond to its surroundings environments in order to increase its effectiveness. Uses include snow skis, baseball, softball bats and shock absorbers in mountain bicycles. For example, K2 Corporation uses a control module produced by active control experts inside a line of its skis. The control module contains a piezo ceramics material that dampens vibrations from the ice and snow, helping keep the skis off on the snow, this enhancing stability, control and utility speed. Worth now has a line of bats that incorporates a similar module. The piezo ceramic control module helps to increase the bat's sweet spot and reduce unwanted skin and off-center hits. The ceramic spark plugs, which electrical insulators, have had a large impact on society. They were first invented in 1860 to ignite fuel for internal combustion engines and are still being used for the purpose today. Applications include automobiles, boat engines, lawn mowers and the like. High voltage insulators make it is possible to safely carry electricity to houses and businesses. Communication. Glass optic fiber have provided a technology breakthrough in the area of telecommunication. Information that was once carried electrically through hundreds of copper wires can now be carried through one high quality transparent silica, that means glass fiber. Using this technology has increased the speed and volume of information that can be carried by orders of magnitude over the which is possible using copper cables. Optical fibers are a reliable conductor for delivering an array of interactive service using combinations of voice, data and video, whether it is multimedia and video application. High speed data transmission and internet access, telecommunicating are sophisticated and demand service. Optical fibers make it easier to communicate. Next we will see about Ceramics in medical applications. Ceramics are becoming increasingly useful to the medical world. Surgeons are using bioceramic materials for repair and replacement of human hips, knees, and other body parts. Ceramics are also being used to replace diseased heart valves. When used in the human body, implants are even as coating to metal replacements. Ceramic materials can stimulate bone growth, promote tissues formations, and provide protecting from immune system. Dentists are also using ceramics for tooth replacement, implants, and braces. Glass microspheres smaller than a human hair are being used to deliver large localized amount of radiation diseased organs in the body. Ceramics are one of the few materials that are durable and stable enough to withstand the corrosive effect bodily fluid. Imaging systems are critical for medical diagnostics. Modern ceramic materials play an important role in both ultrasonic and X-ray computed tomography, that means CT system. Transducer utilizing lead zirconate titanate, that means PZT based piezoelectric ceramics are the heart of ultrasonic system. Transducers generate the ultrasonic acoustic wave and detect the reflected signals to form the image. Ultrasound can be used to examine many parts of the body, including breast, femur, pelvis, prostate, thyroid, and parathyroid, and the vascular system. Most commonly, ultrasound is used during the first, second, and or third trimesters of pregnancy. New developments in ultrasound now enable doctors to see reliable image of in the blood vessels, some things doctors have never been able to see before. This may allow doctors to better identify those at risk for stroke because of its ability to more clearly illustrate the flow of blood, the walls of cardiac and the movement of plaque. X-ray, CT scan are now a common diagnostic procedure in hospitals and clinic sites to image selected region inside the human body for detection of cancer and other disease. For CT scan, an X-ray detector is a crucial component that must have high efficiency to obtain high quality image. In 1988, GE Medical System unveiled an ultra high performance detector with breakthrough ceramic scintillator, which gives better images using lower X-ray doses to the patient. Environment and space applications of ceramics. Ceramics play an important role in addressing various environmental needs. Ceramics helps decrease pollution, capture toxic material, and encapsulate nuclear waste. Today's catalytic converters in trucks and cars are made of cellular ceramics and help convert hydrocarbons and hydromonoxide gases into harmless carbon dioxide and water. Advanced ceramics components are starting to be used in diesel and automotive engines. Ceramics lightweight, high temperature, and wear resistant property results in more efficient combustions and significant fuel saving. Ceramics are also used in oil spill containment booms that corral oil so it can be towed away from ships, harbors, and offshore oil drilling rigs before being burned off safely. Reusable light-weighted ceramic tile make NASA Space Shuttle program possible. the 34,000 thermal barrier styles product, the astronauts and shuttles aluminum frame from the extreme temperature, that means up to approximately 1600 degrees Celsius, encountered upon re-entry into the Earth's atmosphere. While the list could go on, one can begin to the critical impact of ceramics have played in our past and present and will continue to play in the future. Next we will see about composite materials. First I will introduce to composite material. The composite material is a material that consists of one or more discontinuous components that are placed in continuous medium, that means matrix. In a fiber composite, the matrix binds together the fibers, transfers load between the fibers and protects them from the environment and external damage. Composite materials are shortened to composites or microscopic or macroscopic combinations of two or more distinct engineered materials, that means those with different physical and chemical properties with a recognizable interface between them in the finished product. For structural applications, the definition can be restricted to include those materials that consist of reinforcing phase such as fibers or particles supported by a binders or matrix phase. Wood composites are commonly seen examples of composite material. Other features of composites include the following. First one is the distribution of material in the composites is controlled by mechanical means. Second one, the term composite is usually reserved for material in which distinct phase and separated on a scale larger than atomic and in which the composite's mechanical property are significantly altered from those of the constituent components. The composites can be regarded as a combination of two or more material that are used in combination to rectify a weakness in one material by a strength in another. Fourth one, a recently developed concept of composites is that composite should not only be a combination of two material, but the combination should have its own distinctive property in terms of strength, heat resistance, or some other desired characteristics. The composite must be better than either component alone. Composites were developed because no single homogeneous structural material could be found that had all of our desired characteristics for a given application. Fiber refined force composites were first developed to replace aluminum alloys, which provide high strength and fairly high stiffness at low weight but are subjected to corrosion and fatigue. An example of a composite material is a glass refined force plastic fishing rod in which glass fiber are placed in epoxy matrix. Fine individual glass fibers are characterized by their high tensile stiffness and very high tensile strength, but because of the small diameter have very small binded stiffnesses. If the rod were made only epoxy plastic, it would have good binding stiffness but poor tensile property. When the fiber are placed in the epoxy plastic, however, the resultant structure has high tensile stiffness, high tensile strength, and high binding stiffness. The discontinuous filler phase in a composite is usually stiffer or stronger than the binder phase. There must be substantial volume fractional of the refined force phase, that means about 10% present to provide reinforcement. Example to exist, however, of composites where the discontinuous phase is more compliant and than the matrix. Natural composites include wood and bone. Wood is composite of cellulose and lignin. Cellulose fibers are strong in tension and are flexible. Lignin cements these fibers together to make them stiff. Bone is composite of strong but soft protein and hard but brittle minerals. Particular composites, example, various geometry shapes like cubes, spheres, flakes, etc. Various materials like rubber, metal, plastics, etc. have generally low strength, will not be treated further in this course. Particle reinforced metal matrix composites are now being produced commercially, and in this course the current status of this material is reviewed. The different types of reinforcement being used together with the alternative processing methods are discussed. Fiber composites. Classification of composites. Matrices. Organic matrices composites, that is called as OMCs. Polymer matrices composites, that is called as PMCs. Carbon-carbon composites. Metal matrix composites, that is called as MMCs. Ceramic matrix composites, that is called as CMCs. Reinforcement, that is known as fiber reinforced composites, laminar composites, particulate composites. Carbon fiber is a polymer and is sometimes known as graphite fiber. It is very strong material that is also very lightweight. Carbon fiber is 5 times stronger than steel and twice as stiff. Though carbon fiber is strong and stiffer than steel, it is lighter than steel, making it the ideal manufacturing material for many parts. These are just few reasons why carbon fiber is favored by engineers and designers for manufacturing. Next we will see about properties of composite materials. High strength weight ratio. Fiber composites are extremely strong for their weight. By refining the laminate, many characteristics can be enhanced. A common laminate of say 3 mm copper strand mat is quite flexible compared to say a 3 mm plate. However, it will be bent a long way more than the plate before yielding. Stiffness should be not confused with strength. A carbon fiber laminate, on the other hand, will have a stiffness of many times that of mild steel of the same thickness. Increased ultimate strength, yet only be less than 1/4 of its weight. Light weight. A standard fiberglass laminate has a specific gravity in the region of 1.5 compared to alloy of 2.7 or steel of 7.8. When you then start looking at carbon laminate, strengths can be many times that of steel, but only fraction of weight. A DVD case lid was produced using carbon fiber to reduce the case overall weight so that it could be carried as cabin baggage whilst traveling, and for improving security it was used by supporting crew for All Blacks during their 1999 Rugby World Cup Championship. Fire resistant. The ability for composites to withstand fire has been steadily improving over the year. There is 2 types of system to be considered. Electrical properties. Fiberglass Development Limited produces the insulated support straps for the trans-rail main trucks electrification. The straps, although only 4 mm thick, meet the required load of 22 kN as well as easily meeting insulating requirements. Then we will see about chemical weathering resistance. Composite products have good weathering property and resist the attack of wide range of chemical. This depends almost entirely on the resin used in manufacture, but by careful selection resistance to all but the most extreme conditions can be achieved. Because of these, composites are used in the manufacture of chemical storage tanks, pipes, chimneys and ducts, boats, hulls and vehicle bodies. FDL manufactured architecture plans for the construction of marine centers. Composite panels were chosen because of their ability to withstand salty seaside conditions without corrosion. Next we will see about color. Almost any shade of any color can be incorporated into the product during manufacture by pigmenting the gel coating used. Costs are therefore reduced by no further finishing or painting. Soluble dyes can be used if translucent product is desired. We do not, however, recommend dark colors. These products excuse heat surface which can lead to the surface showing print through where the resin matrix cures more and strings, bringing the fibers to the surface. In extreme cases, delamination can occur. Polyester resins are widely used to manufacture molding and sheetings. Light transmission of up to 85% can be achieved because of the versatility of composites product design only limited by your imagination. Low thermal conductivity. Fiberglass development has been involved in the development and production of specialized meat containers which maintain prime cutters of chilled meat and the correct temperature for export market. They are manufactured using the RTM process with special training force and foam inserts. Manufacturing economy. Fiberglass developments process several models of fuels, pumps, covers for fuel cubes. Fiberglass in an ideal material for producing items of this type for many reasons, including being very economical because of its versatility property. Fiberglass can be used in many varied application fields. Advantages of this material: low density, that means 20 to 40%. Higher directional mechanical property, that means specific tensile strength. The ratio of the material strength to density 4 times greater than that of steel and aluminium. Higher fatigue endurance. Then next, higher toughness and then the ceramics and glasses. Next one is versatility and tailoring by designing. Easy to machine. Can combine other properties, that means damping, corrosion, etc. The cost is very low, so we can use this composite for many field of uses. Dear student, in this episode we will discuss composites, cements, concretes and ceramics, etc. The next topic will be discussed in the next episode, that means episode 4.